I am Anil Kumar. Welcome to my series on mechanics. In mechanics, we do have many examples where vectors application is there, and in this particular video, we will learn how do we find angle of vector from x-axis and from y-axis. Well, in case you want to learn from me, you can always send an email on the address given here. Also, check the latest videos on the given website. One question which we are going to answer in this particular video is how do we find the angle the following vectors make with the unit vector I and with the unit vector j. Well, we'll write down the answer to three significant figures. Now, I hope you understand what is a unit vector. Well, the unit vector, as the name suggests, has a magnitude of 1 unit. That is it. But as you know, vectors have both direction and magnitude. So magnitude of unit vector is 1 unit. When I say I, that really means we are talking about a vector which is along the x direction. This positive x direction, that is a unit vector I for us. And the vector j is a vector defined along the y axis. It is the unit vector means one magnitude and the direction is along the positive y-axis as shown here. So that will be our j. We may write these vectors as I cap and j cap or say it as I cap and j cap, right? Otherwise, as you know, the bold letters indicate vectors, or sometimes we do write vectors with a direction as shown here. Correct? So all nomenclatures are, there for writing the vectors. So I hope now it is absolutely clear. The question here is we need to find the angle which a vector makes with either the x-axis or the y-axis, right? So we'll call this as one of these angles, right? That is one angle which we are interested in finding, the vector AB making with the x-axis, right? The other angle which we are interested in finding is what is the angle which it makes with the y-axis, right? So that is the angle which we are looking into. Of course, they are related most of the time. You can always find from 90 minus that angle to get your result, right? Anyway, we'll look into this. Okay, as an example, we will first begin with a general solution, right? So we'll begin with general solution. And then we'll take up practice questions. And these are the 6 practice questions which we are going to take. You can actually pause the video, copy these questions, try answering these questions. The important thing here is when you want to find the angle which a vector makes with x-axis and y-axis, we have to apply a strategy depending on in which quadrant the vector is. So the vectors shown here are in all one by one different quadrants and you'll learn the strategies. Okay, so let's discuss the general method. So here we'll take up the general solution. We need to find the angle, the vector. We have named the vector as a general vector P, AI plus BJ, which makes with the unit vectors I and J. Now, the value of A and B are real numbers, right? Where A and B, they belongs to real numbers. Now, depending on whether they are positive or negative, the vector may lie in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. Correct? Now, also remember when we say that the vector P is equals to AI plus BJ, we basically are saying it's a position vector. Correct? So position vectors will start from the origin. So that becomes the origin from where the vector is going to start. And it will end up with the coordinate point a comma b, right? So we can say that the vectors, as you know, has a tail where they begin from, which will be the origin, and they have a head where the end, and that is going to be the coordinate point AB. So we'll take different values of A. They could be positive or they could be negative. Depending on that, the vector may lie in quadrant 1, quadrant 2, 3, or 4. So one by one, let's take the cases. So let's begin with the vector in quadrant 1. In that case, clearly the value of A is greater than 0 and the value of b is also greater than 0. Both are positive. So we have a vector in quadrant 1. Now, how do we find the angle which the vector makes with the x-axis, which is the unit vector I? So here the unit vector will be, this is going to be a unit vector I, and that is going to be the unit vector j. Let's see, how do we figure out the angle which this vector makes with the x-axis? Well, let us say that the angle made is this with the x-axis. Let's call this angle as, let's say, let's theta. Okay. Now, the coordinate point where the vector ends, as we have taken the case, will be AB. Now consider a triangle which can be drawn, correct? Dropping a perpendicular from point, let's say P, to the x-axis. In this case, you can clearly write that tan of theta is equal to B over A. And that means theta is equal to tan inverse of B over A. So that gives you the value of theta. Now this angle, theta, is with the x-axis with vector I. So that is our first solution. Now let's look into the other angle, which is the angle J. Angle with J is the angle here. Let's call this angle as phi. So angle with the y-axis is phi for us, and clearly, as you can see from here, phi is equals to 90 degrees minus angle theta. So that becomes the case when we are talking about the vector in the first quadrant, correct? So we are going to write the vectors as phi and theta. Phi with actors with j, and angle which vectors make with the x-axis will be written as theta. Now let's take the second example in which the value of a is, as you can see, negative, less than 0. However, b is greater than 0. In that case, the vector will be in quadrant 2. So let's have this vector here with the origin at 0, 0, and the point here will be AB, correct? The angle which it makes with the y-axis is phi, and the angle which it makes with the x-axis, which is with I, is theta. So these are the two angles which we need to find. Well, the process is going to be same. We'll find the value of tan theta. So what is the value of tan theta in this case? Now, it is better to find the value of acute angle. So now, what we are going to do is to find the related acute angle and then find the value of the angle with x-axis and with y-axis. So let's say this acute angle is beta. That is what we are going to do. I hope you remember. In trigonometry also, whenever you want to find any angle, it is first better to find the related acute angle. So find the related acute angle. We'll talk about this angle beta. Consider the points as positive. So the tan beta is equals to the absolute value of b over absolute value of a. And from here we get the value of beta as tan inverse of absolute value of b over absolute value of a. The idea here is whenever you find the related acute angle, which is what? Which basically is the angle which you make with the horizontal axis, right? So it is actually angle with horizontal axis, which is the x-axis, correct? That is what the related acute angle beta is. So we found that beta in this case is tan inverse of absolute value of b over e. From here we can find theta. So in this case, theta is going to be 180 degrees minus beta, and angle phi is going to be 90 degrees minus beta. I hope that makes sense, right? So phi will be 90 minus beta, since this angle here is 90 degrees, correct? And theta will be 180 degrees minus beta. So if the vector is in quadrant 2, first find the related acute angle and then adjust for the answers. That is our strategy. Perfect. Now let's take the next example, in which we'll take the value of a as less than 0 and b also as less than 0. All the quadrant points in this particular case will be negative, right? So we have a point here, P, which is AB, where A is less than 0 and B is also less than 0. Let us say this angle here is the related angle beta. So we'll find what is tan inverse of B over A, right? So that is to say, first step, as we did earlier, we'll find the angle beta, which is equals to tan inverse of absolute value of B over absolute value of A. Perfect. Okay, I want to write B over absolute value of A. That is the tangent of this. And now from here you can find what is the related acute angle for with the y-axis. Let's write down this first, and that is we are writing with the letter phi. So in this case, phi is equal to 90 degrees plus beta, and theta, the angle with the x-axis, is what? This angle theta will be equal to 180 degrees plus beta. Is that clear to you? Right? So I wrote this time the angle with the y-axis first and then with the x-axis. The last example here is when a is greater than 0 and b is less than 0. In that case, the point will lie in quadrant 4. So as shown here, the position vector will be in quadrant 4. Let's say the quadrants of point P are A, B, right? Now in this case, what is beta equals to? Well, beta remains same, which is always tan of absolute value of B over absolute value of A, tan inverse of this, correct? Now from here, we need to find the angle. Let's write with I, which is for us theta, right? So this is angle theta. Theta is going to be how much? It is 360 degrees minus beta, and the angle which is phi will be how much? Well, the angle phi, which is with J, will be equal to, as you can see clearly here, 270 minus beta, right? So it is 270 degrees minus beta. So these are the different ways of finding the angle of the vector with unit vector I or with unit vector j. So see how. First, you need to find the related acute angle, beta. Once you do that, which is with our common formula, right? Beta is equals to tan inverse of absolute value of b over absolute value of a. Once you have the angle beta, figure out in which quadrant the vector lies, and then accordingly use your rules as we have done here to get the answers, right? So I hope that is absolutely correct. Now, if you are in quadrant 1, acute angle and the angle which it makes with the x-axis are both same, right? So in this case, we know beta is also equals to the related acute angle is equal to the angle which the vector makes with the x-axis or with unit vector I. Now, with that in mind, I hope the concept is absolutely clear. Let us take our practice questions. The very first question here is to find the angle the vector A, 10i plus 8j, makes with the unit vectors I and j. So first step here should be to sketch the vector on the quadrant plane. So here I have sketched the vector. When I say that the vector is a 10i plus 8j, we really mean we're talking about a position vector, right? It is a position vector. We'll call this vector with origin as the tail, right? So tail is the origin, okay, and the head is at the point which is in this case 10, 8. With that in mind, I've sketched the vector shown here, right? So this is the vector which reflects the vector A as written here. Perfect. Tail being at the origin and the head being at the point A, 10, 8. Now, to find the related acute angle, which can be shown right here as given here, this is the related acute angle for us, beta. So this related angle, beta, will be equals to tan of beta will be the change in y value of change in x value. In this particular case, y is 8 and x is 10. So the ratio of 10, 8 to 10, which is 4 over 5, beta will therefore be equals to tan inverse of 4 over 5, and that gives you a value of 38.65. We need to write our answers to three significant figures, right? So we are going to round this up as 38.7. So we now know that the angle which it makes with the vector I will be same as the related acute angle beta, which is 38.7. And the angle phi that it makes with the y-axis or the vector j will be how much? Well, it has to be 90 minus 38.7. That gives you 51.3 as your answer. Is that clear to you? In red, I have shown here the unit vectors. Note, the scale is each square is equals to 2 units. And therefore, we get this point A as 10, 8. Once again, unit vector I is a vector in the direction of the positive x-axis with the magnitude of 1 unit, and the unit vector j is a vector in the direction of positive y-axis with magnitude of 1 unit. Clear? Now let's take the next example. I hope you have understood the concept. We have a vector which is b minus 3i plus 4j. Now clearly, when the value is minus 3i plus 4j, we know this vector will lie in quadrant 2. Since this vector is in quadrant 2, as shown here in the diagram, we need to find, the first step is to find the related acute angle. Correct? Right. So after you sketch the vector and figure out that it is in quadrant 2, you need to understand that first step should be to find the related acute angle beta. And once you find that, then you adjust it to get your answer. The two values which the vector makes with the unit vector I and with the unit vector j. Is that correct? Perfect. Now, in some books, we have seen the method of finding the change in ratio as change in y over change in x, and that is why I'm writing it. But I prefer you to write this as we had been talking about. So you always write tan beta as equal to the absolute value of b over absolute value of a. We are assuming always that the triangle is being formed in quadrant 1. Is that clear to you? So we actually forget about the sign and then we say, well, this is 3 and 4, 1, 2, 3, and 4. So we consider the vector being, let's say, b dash, right? So we are trying to find this value. Let me say this value is alpha. So that is the value which we normally find. We write beta and we consider all the points as positive. Correct. And therefore, from here, beta can be written as tan inverse of absolute value of b over a as we had done in our general solution. Perfect. Now here is another method. Of course, we are writing the same values 4 over 3. Absolute values we have written, correct? So this change is considered to be the like a distance. You understand distance is always positive. That's what I meant by writing like this. Okay, so we get the value of beta, the related acute angle in this case, as 53.13. So the angle here, beta, is 53.13 rounded to 1. Okay, now we need to find what the theta angle is, which it makes with the I vector with vector I. It is this angle, correct? So that is 180 minus 53.1, 126.9 is what we get. Now let me round this answer to three significant figures. So I'll write this answer to 127 degrees. Perfect. The next one here is 90 degrees minus 53.1 degrees. When you take away, you get 36.9 degrees as your answer for the direction which the vector is in with the unit vector j. Perfect. So that is how it is to be solved. Now let's take the next example, which for us is find the angle of the vector u, which is minus 6i minus 3j. Both quantities are negative. That means we are working in quadrant 3. So in quadrant 3, as shown here in the diagram, we have the vector u minus 6 minus 3. Now OU will be the position vector u. Is that correct? So it's important to understand OU is the position vector u. Okay, so these are different nomenclatures, right, used globally. So we need to understand them as we move along. Now here, I've shown you a different way. What I've done here is I've actually plotted a point U dash, which is 6, 3, right? So, and from this point, we are saying we'll find the angle alpha. So we are actually finding first tan of alpha, which is the ratio of y to x value. Correct. So alpha is equals to tan inverse of half, right? This is half, correct? Now you could also use special triangles to find your answers. Now that is simple. We have a special triangle which gives you these values. I hope you remember, right? So 1, 2, and square root of 3. So the value for, no, not this half, sorry, uh, not this special triangle for this. This is tan inverse of half. Anyway, you need to use calculator to find this angle, and you get the value of alpha as calculated here as 26.6 degrees, right? So we get this alpha as 26.6 degrees. Now we can find out the angle which the vector makes with vector I and vector j. Now these two angles are opposite angles, so they have to be equal. So this angle is also 26.6 degrees. Now you can clearly see in this case the angle which it makes with the vector I will be 180 plus the related acute angle, and the vector makes the angle of 90 plus 26.6 degrees, which is 106.6 degrees with j. When you want to write them as rounded to three significant figures, this will be written as 207 degrees and this will be written as 107 degrees, right? Remember that. Once again, a reminder of what unit vectors are. Okay, now we'll move on into question number 1D, which says find the vector's angle, which vector v equals to 6i minus 5j makes with the unit vector I and j. So the question is exactly same. First thing to figure out is in which quadrant you are. The value of a is positive and b is negative. Clearly, we are in quadrant 4. So you can see the first step should be sketch the vector and understand in which quadrant are you. So we are in quadrant 4 as shown here. The related acute angle is we need to find first, correct? So I have drawn that dotted line to show you that this is the angle alpha, which I'm going to find first, which in this case is tan beta equals to the change in y over change in x. We'll consider only the positive values, right? So only positive values. The ratio being 5 over 6. Tan inverse of 5 over 6 gives you 39.8 degrees. And clearly, the angle which the vector makes with unit vector I is shown here, which is 360 minus the related acute angle. Does make sense to you, right? So this angle is beta we're talking about. So we can say it is 360 minus the related acute angle 39.8. that gives you the answer. When you round this to three significant figures, you get 320 degrees as your answer. The other angle rounded to three significant figures will be 233 degrees, and that will be 270 minus the related acute angle as shown here, since you are in quadrant 4 this time. Perfect. So I hope with these four examples you have seen how when the vector is in quadrant 1, 2, 3 or 4, how do we solve it, correct? Now here we have taken two more examples mainly to use special triangles, right? So we are now going to use special triangles as sometimes calculator may not be allowed. So this is without calculator. So the first question without calculator is that we have a vector which is p minus 3 square root 3i plus j. You need to find what angle does it make with the unit vector I and what angle does it make with the unit vector j. So as we had been doing, first sketch. When you sketch this value, you know a is negative and b is positive, and therefore you are in quadrant 2. So the sketch clearly shows the vector in quadrant 2. Coordinate point minus square root 3, 1 is the point P for us. Now in this case, let's first step is to find the related acute angle, which is the ratio of the y and x values of this particular vector, 1 over square root 3. Now you remember this special triangle which gives you the relation between all these quantities, correct? So 1, 2 and square root 3, right? So that is a 60-30 degrees triangle. Perfect. So we're looking for tan ratio of 1 over square root 3, and clearly that means the angle should be 30 degrees. So we have the related acute angle of 30 degrees. So beta in this case is 30 degrees. To find the angle which the vector makes with the I unit vector I, which is along the x-axis as shown here, it should be 180 degrees minus the related acute angle. So that is what we have done, and we get 150 degrees as our answer. The angle which it makes with the vector j, a unit vector in direction of y, is 90 minus 30, which is 60 degrees. And that is how you get your solution for the vector p minus square root 3i plus j. Perfect. The last example here related to finding the related acute angles and then the angle which the vector makes with I and j is here. I'd like you to pause the video, try it, and take this as your quiz, right? So without calculator. Okay, so first thing is we are given the vector here, so we'll find the related acute angle. We say, well, tan beta is equal to the positive value square root 6 over positive value square root 2. Well, that gives you square root 3, and therefore beta should be how much? Well, beta is tan inverse of square root 3. We do have a special triangle as we sketched in the last example. The same triangle will work for us, right? 30, 60, 90. Perfect. Here we have 60 degrees. We're looking for square root of 3, the opposite side being square root 3, adjacent being 1, and clearly the right angle triangle which we have drawn here helps to find the answer. So the angle is 60 degrees. Clearly, that is the related acute angle. So we get the related acute angle beta as equals to 60 degrees as shown here. Now, since the point is in, okay, so this diagram is not correct. It is both minus, correct? Okay, this is the wrong diagram. Fine. Let me just re-sketch the diagram. This is not the correct diagram. Okay, let's scrap it. Okay, so I'm re-sketching minus square root 2. This is the diagram of the last figure. Well, here is it. Both are negative, right? So the angle has to be in quadrant 3, right? So we are in quadrant 3 now. In quadrant 3, the angle which we found as a related acute angle was 60 degrees. So this angle is 60 degrees for us. Now, what is the angle which it makes with I. That is the angle, correct? Obviously, it is 180 plus. Okay, so we are actually in quadrant 3, right? So that is the wrong diagram. We are in quadrant 3. So 180 plus 60 degrees. So we get angle with I is 180 degrees plus 60 degrees, correct? Which is 240 degrees. And with J, the angle will be from here, right? Let me use a different ink. Right, which is 90 plus. So with the 90 plus 60 degrees, which is 150 degrees, as shown in this diagram. Perfect. So I hope that makes sense. We had a wrong diagram here. That is the sketch. So you can see the sketch really helps. Draw a correct sketch and then get to the solution as we have done here. So clearly, in this particular case, once you find the related acute angle, you can find the angle which it makes with I and with J. As shown here, the angle with I will be 180 degrees plus the acute angle, and angle with J will be 90 degrees plus the acute angle 60, and that is how you get your answer. Now here is the last question, which actually is a test question for you. Question number 2. An object moves from A to B and then from B to C. We have actually shown here in the diagram an object from A to B and then from B to C. The displacement from A to B is given by the vector 8i plus 5j in kilometers, and the displacement from B to C is given as minus 6i plus 6j in kilometers, right? So from here, minus 6i, so 1, 2, 3 units. Each unit is 2 here on this scale is 2, right? So this is 2, this is also 2. Okay, so we have sketched this part. Find the magnitude of the displacement of AC, that is one part. So we'll leave that for the moment, but we'll focus on find the angle AC makes with the unit vector AB. So that is the question for you, right? So you need to find the angle AC makes with the unit vector AB. So along this vector. So your question is to find this particular angle, which is phi, correct? So I'm writing here phi. That is your test question, correct? So this is your test question to be solved. Perfect. So you have to first find the magnitude and then the direction of the displacement from A to C. Well, remember one thing, that when we talk about displacement from A to C, it is the sum of these two angles, correct? So as shown here, we have the vector AC as shown here. It is sum of vector AB and BC. So add them up. When you add them up, you get the vector AC, which is 2i plus 11j. And now we understand this is in quadrant 1. We need to find the angle, which is theta. Uh, find the angle AC makes with the unit vector AB. We have to find that angle. So first what we are going to find is the angle which it makes with x-axis, right? So we are not using sine or cosine law in answering this question. Perfect. We are using what we have learned here. So angle theta is the angle which is being made with the quadrant AC with I, right? Unit vector I. So the angle theta is the one shown here. This is angle theta for AC. Now, clearly, as the positive y value is 11, positive x value is 2, the ratio of these two will give you the tan theta. So theta is inverse of this. So this angle here is 79.7 degrees. Correct. Now, let's find the angle AB, which makes with I. So now we got this bigger angle here as 79.7 degrees, correct? Now, let us find the angle which AB makes with I. So AB makes with I, the vector AB is given to you as 8i plus 5j. So their ratios will give you this angle as 32 degrees, right? So we get this as 32 degrees. Difference of these two will give you the angle phi which we need. Correct? So, we'll find the angle AC mixed with unit vector AB will be the difference in these two values. So find the difference, you get the answer as 47 degrees. So these are the hints to find the angle on the same lines as we have done rest of the questions. Correct? So that is how you have to do it. Now for you, find the angle AB makes with unit vector BC. That is the next question for you. So let me just mark this question here. It is a question 3 for you. So question number 3, which is part of your test, is now here, which is find the angle AB makes with the unit vector BC. You have to find that angle. Now remember, when you are finding angle between vectors, then both the vectors put tails together. So that means we'll extend this vector here. And what you're really interested in finding is that angle, correct? So that is the angle which you need to find in this particular case. So let's call this angle as gamma. So you need to find the angle gamma, and that is your test question. However, I've given you the answer to check. Perfect. Remember, when you want to find angle between two different vectors tails together. In previous examples also, when we are trying to find angle with the unit vector and the vector, tails were together. Do you see that? So tails together and then you find the angle. That is how you should be doing it. I hope that really helps. With that, we come to an end of this particular exercise in which we learn the concepts of finding what angle does a vector makes with unit vector I, where unit vector I is along the x-axis, and what the angle is made by the vector with unit vector j. Unit vector j is along y-axis, positive. Is that clear to you? So all these examples I hope really help. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.